Even though a DDD app is driven by behavior, we still need objects. DDD expresses two types of objects, those which are defined by an identity and those which are defined by their values. We'll focus first on the objects that are defined by their identity. These objects are called entities.
An entity is something we need to be able to track, locate, retrieve, and store, and we do that with an identity key. Its properties may change, so we can't use its properties to identify the object. If you've done any type of data persistence in software, you're probably pretty familiar with entities and their keys. When we are modeling a problem, we can talk about entities without having to think about how they are implemented in the resulting software. But when it is time to start coding, there are patterns to follow to ensure that these objects have the technical attributes of domain-driven design entities.
As you can see from this section of the DDD navigation map, entities are pretty integral to our software. So before we can learn about these other elements, domain events, repositories, factories, and more, you should have a very good understanding of an entity.
The most important entity in our model is appointment. This is what we will be creating, editing, and retrieving in the context of scheduling appointments. Appointment inherits from a base class we created called entity. We'll look at that more in just a bit. Notice that all of the classes shown here are inheriting from the identity base class. However, although the other classes are entities, after our discussions with Michelle, we came to the conclusion that we would like to have a separate utility for managing client and patient information and to manage information about staff and staff scheduling. Thus, we don't need very much information or behavior related to these collaborating entities within the bounded context of appointment scheduling.
Let's take a closer look at that data that supports scheduling appointments in our system.
We determined that managing the client, patient, and staff information, which is external to this model, was well suited to just simple CRUD. We didn't identify complex rules or behaviors for creating and editing that data. Thus, the concepts of doctors, rooms, clients, and patients are managed outside of the scheduling bounded context.
For comparison, look at the CRUD classes for patient and client in the other bounded context. They are very simple. They don't inherit from our entity base class, and most interestingly, their ID properties are integers. We'll let the database assign the IDs when we create these classes, so these classes are not designed using domain-driven design. Now let's go back to the appointment scheduling context. The client, patient, doctor, and room classes here are completely different from the CRUD classes we just saw. However, they do have a subset of the same fields from those CRUD classes. All we need to know about these objects when we're scheduling is their IDs, their names, and maybe a few other details. But here they're simply used as lookup data, and they're read-only. Even though our domain is split up into a number of bounded contexts, the user interface can be designed in a way that moving from one context to another is seamless to the end users. They don't need to know that these things are in separate bounded contexts. While maintaining client and patient data is a completely separate task from scheduling appointments, Michelle wanted to be sure that anyone working at the front desk is able to easily move between these tasks in the software without disrupting their workflow. So let's say the person at the clinic who does the scheduling is on the phone with Kim and about to make an appointment for Roxy to come in. But then the other line rings, they put Kim on hold, and it's me. And in the nicest way possible, I've called to just let her know they've got my last name spelled wrong. That happens all the time. People just want to put that H in there. Even though they're in the middle of scheduling, and scheduling has its own back end, its own bounded context, and is totally separate from client management, they can still drive the app right over to the client management area and very quickly fix my name and save that. Then they can just flip back to the schedule. Notice that Kim is still the active scheduling client that's showing up in the left-hand corner. And the change to the spelling of my last name is already visible on the schedule. And so now that person can go ahead and finish up with Kim scheduling the very adorable Roxy for a wellness exam. To the user, there's no real difference between doing the scheduling and doing the client management. It's just a nice, smooth flow between the two, It doesn't feel like, oh, now we have to open up a different application in order to do this other thing, and doesn't break everything they're in the middle of. But for the purposes of designing our application, everything is bound within its own individual context. And when designing these contexts, we don't have to worry about switching from one context to another.
So remember, we're talking about what makes these all entities. An appointment object needs to be located and tracked, and we need to be able to edit them easily. Using a unique identity allows us to persist and retrieve an appointment, even if some of its values change. Appointment is definitely an entity in our system. We actually had to think a little more about client, patient, doctor, and room in this particular context. Our discussions highlighted the fact that when creating appointments, we only need access to some of the high-level information about the client, patient, doctor, and room, but these objects won't be edited. So we wanted these stripped-down, read-only types that give us minimal amount of detail for each. We do still need to be able to uniquely identify them, though. I mean, they do have some identity. If the client's name changes, a change we would make in the client management system, that new name will need to be reflected when we look at the appointment scheduling for that client.
There should only ever be one record to represent a particular client in this bounded context.
So client and the other types that are reference types in this context are still entities. We triple-checked our decision with another kind of domain expert, Vaughn Vernon, a DDD expert, and we were happy to get his thumbs up on this particular decision. So Julie, Michelle, and I also talked about how to name the types that are simply reference types in this particular bounded context. At first, we were worried that we might get confused by having different definitions of client, patient, doctor, and room. We wanted to call them client details or client view or something like that. But thanks to the ubiquitous language, the fact that we are in the scheduling context drives our comprehension of what a client means in this particular space.
A client in scheduling is still a client, so we use the same name, even though it's a differently defined type than the client we work with in the client-patient management app.
Right, and thanks to namespaces in our code, we're able to keep it clear which ones are which in the code.
So all of these types inherit from our base entity class. However, notice that those reference types use int for their base entity's ID and not the GUID that's used by appointment. That's because all of the management of those other types happens to be done using CRUD, and with CRUD, it's easy to just use database-generated ints. Appointment is built using DDD principles, and you'll see that it's much easier to use GUIDs when building DDD entities and the related logic rather than relying on the database to provide the identity values. Not only is it easier, but it follows DDD principles more clearly, since we will build all of our domain logic around appointments without involving the database. We would have a hard time working with appointments in our model and in our unit tests as we develop the application if we always needed a database to assign their IDs.
So that's not to say that you can't use integer IDs if you're going to use a DDD style of application. It just makes it a little harder, wouldn't you say, Julie?
Yeah. And I've definitely come up against that. With the stuff that I do with Entity Framework, I've made sure that I show patterns for continuing to use the database-generated ints because I didn't want to give people the impression that they had to throw away, like for me, like 25 years of this dependency, right? And like all of a sudden I have to go cold turkey and move over to GUIDs.
Sure. I mean, there's trade-offs in what you choose to use for your ID.
Yep.
But having an ID that we can generate in the client and just in our code has a lot of value.
Every time we've been working on some of our different unit tests and we needed, as part of the test, to instantiate something that was an int, we were like, now we have to find another way to get that in there because we were protecting it, and it was a problem. As our own experience grew, we realized there's another way to bridge this conflict by using both GUIDs and database-generated ints in an entity. This way, while creating objects, you've got the control over key generation with the GUIDs, and they're not depending on the database. However, once the data has been created in the database and int keys exist for it, then you can benefit from those when adding indexes and performing queries in the database.
We talked with Eric Evans to gain some additional insight into entities, specifically I asked him how entities align with the single responsibility principle.
If you're not familiar with this object-oriented programming principle, you can learn more about it in Steve's Solid course right here on Pluralsight.
One of the questions that I've heard is, what is the single responsibility for an entity? Or to put it another way, does having an entity that has a lot of business logic in it violate the single responsibility principle?
Eric told us that entities are very central, and so it's natural that they get heaped up with lots of functionality.
But there's a downside to this. As you build out the system, there are more and more conflicting demands for these central entities, so they end up being huge. Evans said that the main responsibility is the identity and the life cycle.
Eric also told us that single responsibility is a good principle to apply to entities, and it points you towards the sort of responsibility that an entity should retain. Anything that doesn't fall into that category, we ought to put somewhere else.